taking apart the high pressure water pump. There's the way it works is two check valves, one here, that's the actual hexagonal fitting hex valve proper. Check valve. Check valve right there that says neutral, NEU-TROL. That's the company that makes these little check valves right here. And then there's a pressure gauge here. It goes all the way to 3000 psi. This is the water outlet. Water inlet is at the bottom here. That's just hose water. That's the inlet. You can connect a hose to that. So we're looking inside the pump to see what's in there. Oh wow, so all you got is the space here. So two O-rings, one and one here, and that's it. That's all we have. Interesting. So no groove on the inside of this. That's just a straight hole through.
Yeah, and then this is just basically a little place where you pack grease to keep it lubricated. That's what that void is right there.
Mm-hmm.
So,
oh, I see.
And then the water, because the water actually comes in here. Okay, so that when you pull that back, it draws it in.
Mm-hmm.
Then when you push it out, it can't go back through the check valve. It has to go that way.
Yeah.
And then there's a check valve here, because if you didn't have this check valve, the boiler or whatever you're pressure checking, the pressure would want to come back through here and it would blow this out of here.
Mm-hmm.
So.
Wow, so that's pretty simple.
Yep.
Does that space between the two O-rings matter, or that's?
I would have it in there. He obviously designed it to have that in there for some reason, and I'm sure it was for lubrication. Because there's no other way to lubricate this thing. So it's just a pocket where you can keep some grease in there.
And does the length of that matter, you think? Or?
I don't know.
Yeah.
I don't know. I don't have any specifications on it or how or why he designed it that way.
Let's measure this. Is that like ½ inch, or you got a tape measure? We did.
That's probably ½ inch. And it wouldn't be cold roll because
here's a tape.
On that is
here we got one.
Your tolerances on that are not as good. Oop, there you go. Yeah, that's ½ inch.
And the space between the O-rings?
Space between the O-rings is just about 1 inch, just like 15/16.
And the O-rings, those would be ½ inch O-rings? Is that what they would call them? If it's 1 inch OD, or?
Yeah, it would be just a ½ inch O-ring.
Yeah, and here it's just bolted through with what are those hex?
They're called button heads. Button head.
Tell me about those.
They're just a hardened. They're a hardened bolt. And they're similar to what you call an Allen head bolt, because you use a hex key to tighten them.
And they go into each other? Is that what happens inside?
I doubt it.
Oh, those are just.
They're just making this linkage where the handle. They're just connecting the handle to the body of the pump itself.
Here, let's measure this. If you want to build one of these, give me some more measurements. So you got the shaft.
And this, you'd have more leverage if you wanted to build it a little longer.
Well, this one's 9 inch.
That's 9 inch. Then your
distance between the holes there.
That's 1.25 inches. But that depends on
on the height.
Obviously, the height of your pump and the size of your pump. Bottom bolt down here is a 1/4 bolt.
And these linkages are how long?
These linkages are 1 3/4 inch, 1 3/4 basically.
And the body of the pump?
This body of this particular pump is 3 3/8.
And the width?
The width is probably 1 inch stock.
Mm-hmm.
Yep,
1 inch stock.
It's just probably 1 by 2 inch
1 by 2
aluminum
inch
stock.
aluminum stock cut off at the corner.
Yep, and he just machined it so that.
And is it stuck to the bottom? That's just how's it connect to the bottom? To the base.
It's
that like
probably it's probably bolted in from underneath here.
Mm-hmm.
You can't tell really because it's
There's no, I don't see any bolt
well,
holes down there.
you know what it is. I believe there's
There's underneath this plate here.
yeah, there's
It's just threaded in there. And recessed bolt heads.
what they call stove bolts probably in the bottom.
Mm-hmm. With recessed heads, or
Yeah.
so they don't go into the bottom.
Yep.
Mm-hmm. Good. Let's see. Let's take this thing out again. Can you measure the whole thing? What's the length on that?
Sure.
Again?
You might as well. You can, as long as we're here. All right, take care, Otto.
Yeah.
Total length of this shaft is
3 1/4.
3 1/4.
Because you can make a valve like this exactly the same for hydraulics.
And we can also measure the stroke once we get this back together. But I'm going to go ahead and take this off the platform, and we'll see if we can see how it's assembled together in the bottom.
If that's 3,000 psi, why are hydraulic valves that much thicker? I don't know. This maybe because it's hydraulic valves should stand higher shocks.
No, higher volume. You can only put half a gallon a minute through this.
Okay, yeah.
You know, on a big valve like a hydraulic valve, they're made to handle gallons per minute of flow.
Yeah.
You know.
Okay.
So. Yeah, and most hydraulic valves, 3,000 psi is kind of like the industry standard. Everything is rated for 3,000 psi operation pressures.
Mm-hmm.
It's being uncooperative. Yep.
Oh, yeah.
There's just a couple of Allen head bolts.
Okay.
With countersunk holes.
Yep. That's a pretty powerful device. Up to 3,000 psi just with hand strokes. Yeah, it's good. Well, just like hydraulic jacks.
Yep. Same principle.
Mm-hmm.
We just use water instead of oil.
Mm-hmm. Yep. And base there is just 5 inches long across 2.5. It's about half inch stock. Yep.